All right, welcome to section 11.9 about normal distributions. And if we're kind of going to learn like what the heck a normal distribution is, draw and then calculate percentiles given normal distribution. Okay, so a distribution just shows how like the data is spread out, and oftentimes you might put it into this like called a histogram, and like this represents all the people that had shoe sizes between 4.5 and 6. So it's probably just one person, right? And this is actually some data I took from students. You can see the highest was between 9 and 10.5. Okay, and that's called the distribution of data, right? And so it makes these little shapes, what they're going to call curves. All right, and so there's lots of possible distributions. Three are shown here. We have what's called normal, where it looks like symmetrical. I think that's why it's called normal, is like this half looks exactly the same as that half. And then you can be like skewed towards the positive and skewed towards the negative. Okay, so really we want to focus on what's called a normal distribution. And please know that not all data is normally distributed, right? Sometimes you might have these different types of distributions, but this lesson is going to be specifically about normal distributions. Okay, and so here's just another example of, I had the students guess my weight, right? And it's not quite normally distributed. It's a little bit, got a longer tail on this side, right? But if you want an example, right, I also did this with my students where I had them flip a coin and record the number of times they got heads. And this is the best example I can give you of something that should be a normal distribution. If I ran this with thousands and thousands of students and plotted their results, I would eventually get a nice curve where the two halves are the same. Sorry, this half doesn't look very good, but if I did it enough, I would get exactly symmetrical, right? Centered around 5 would be the mean or the average. And then the reason to be symmetrical is your chances of getting 4 heads is the same as your chances of getting 6. Same with 3 and 7, 2 and 8, 1 and 9, and then you can see no one got 0 or 10, and those are very unlikely. Okay, so this is a normal distribution because the two halves are the same, symmetrical, and also most of your data, you can see it here, falls in the middle. Right? Not too many people got a small number of heads or a very high number of heads. Right? And that is true because it's a 50% shot. So it's not surprising most of our data is going to be in the middle. Okay, and that's another property of normal distributions, is the data is generally centered around the mean. Okay, so normal distributions, if data is normally distributed, which doesn't happen all the time, but if it is, then we're definitely going to relate it to standard deviation. So basically, we're going to like go out one standard deviation in each direction. That's kind of showed by the red clumps in these pictures. I'm trying to move these up a little bit. And then we'd go out another standard deviation that represents the green ones. And then we jump out a third standard deviation, that's the blue ones. So we go up or down one standard deviation, then we go up or down 2. And then again, the blue represents going up or down 3 standard deviations. So it's going to go out in each direction. Okay, and if it's normal, the two halves will look the same. And then one of the things these normal distributions tell us is how spread out the data is. So if we look at these and think back to our lesson on standard deviation, which one of these two would have a higher standard deviation? You could pause the video, give it a shot. Okay, and the answer is the one on the right. So we don't actually know what the standard deviation is, but let's say that this one's like 7, and the one over here would have to be something less than that, like 3. You can sort of see it here, right? Like as we jump out of standard deviation, we're not going very far, versus here it's a little bit more smushed and we go out farther each standard deviation. Okay, so basically what this shows is that the data isn't spread out very much. They're all packed around our mean, right? Our mean is going to be right in the middle. I didn't say that already. That's the mean right there. And so here they're tightly packed to that mean, and here they're spread out a little bit more. Okay, so this idea of standard deviation very much ties into normal distributions. And most of your data, in fact, we're going to learn here in a second, 68% of your data will fall, in a normal distribution, will fall one standard deviation from the mean, right? So you have about 34% here and 34% here. My favorite example for normal distribution is actually the height of both males or females. This one happens to be the one for males, and you can see the one here, the solid line is the standard deviation of US men. And then somebody thought, I thought this was kind of funny, they did a dating site, OkCupid, and then they looked at all the heights listed on there. All right, and so basically you can see it's still a normal distribution, but it just got shifted a couple inches taller. I think it was about 2 inches taller. Okay, and so I thought, like, what would you conclude from looking at this? If you see that it's about 2 inches shifted towards the taller, what do you think we can conclude? Okay, and I think what I would say is they're probably just lying. Like, it's not like OkCupid has tall men that are taller than normal, right? Especially if you have enough data. It's probably just because they're all lying and they lie by about an average of 2 inches, right? So if you're a female on the site, you could just assume the person on their profile is probably 2 inches shorter than what they actually list. Okay, one final question here to make sense of like a standard deviation and normal distributions. So you can see there's two normal distributions here, right? The mean in the middle and the standard deviation. So my question is, which set of data, right? Assuming that that data generated those normal curves, which set goes with which normal curve? Pause the video and give it a shot. Okay, and so your answer is this first set has a lower standard deviation, meaning they're more tightly packed around that mean of 50. So this set of data would go with that normal distribution, and then this one, because they're a little more spread out from the 50 in the middle, right? It would have a higher standard deviation. And it would look like that. So that's just again to help us make sense of what a normal distribution is showing us. All right, so I believe what I want to do next is talk about how you use normal distributions to find percentiles or percentile rank. All right, and it's going to be all related to this graph, and you can draw one of these. Otherwise, I think I put a note sheet out on Schoology. We could print some of these off and then fill them in so you have a nice detailed picture. All right, because that's the guts of like finding these percentiles. So first couple things, Z-score is just like how many standard deviations you are from the mean. So like, let's say the standard deviation, let's say the standard deviation was 8 and the mean was say like 20. Maybe that's not high enough. Let's do 50 or something, right? So we'd have 50 in the middle, and then if we went up to 58, that would be considered a z-score of +1 because you're one standard deviation above the mean. Similarly, if you went down 8 to 42, that score would be considered a z-score -1 because you're one standard deviation below the mean, right? And so forth and so on. So this 34, right? If we went down another 8, that would be 2 standard deviations below the mean, and it has a negative z-score because we're below, right? And so forth and so on. This would be 66. That would be considered +2 because there's 2 standard deviations above the mean. And that's the z-score. Okay, so what happens is in normal distributions, generally speaking, there's going to be 34% of the data on each one of these little chunks. So if I go down 1 standard deviation and between 0 and -1, that's 34% of the people fall there, right? Similarly, since it's symmetrical, there'll be 34 on this side. The next chunk out is 13.5. So 13.5% of the data falls in there. The next one out is a little bit more than 2%, so it's 2.35. Sorry, my thing is failing to write here. And then also 2.35 over here. And the last chunk is just a tiny percent, less than 1%, 15 hundredths of a percent, falls in those very tips. So very few people are above 3 standard deviations or below 3 standard deviations from the mean. Okay, and so like how we're going to use this is we're going to basically say, let's take the score 58, right? That percentile rank, if this was the standard deviation and mean, the percentile rank for 58 would be, I think, 84%, because we'd be ahead of or equal to 84%. And I can get that by adding up all the chunks that are below me, right? And you could add them all up, would be fine, but please know that it's 50% this way, right? And then 34. So if I do 50% from this side over plus the 34, that's how I figure out that this spot is the 84th percentile. So anyways, we're going to draw these standard deviation normal curves and then answer percentile questions based on that. It won't always be percent rank, but anyways, we'll do some examples that'll make sense. So one classic one of these is IQScore. So they have a mean of 100 and a standard deviation of 15. So we're going to draw this normal curve, which is nicely already done for us. We're just going to label it and then figure out these percentiles. I shouldn't say percentiles, just percents is what we're finding. Percentile is what you're ahead of or equal to. So we're just finding percents. All right, so anyways, right in the middle goes the 100. And then when I go up or down one standard deviation, I'm just going to add the deviation amount. So this would be 115, this would be 130, and 3 standard deviations above the mean would be a score of 145. Subtract 15 going this way, so I'd have 85, 70, and 55. Okay, and so I would pause the video and see if you can do these on your own, right, before watching the answers. Okay, so less than 115, this would be a percentile rank. So if I go to 115 and go less, again, I would add up all these chunks, but it'd be 50% plus the 34% would be 84. Right, you could also add up these ones over here and then do 100 minus that chunk. That would be another way to do it. So more than 115, well, we kind of already have that. If less is 84, then 16% here. And add up all those little chunks and get 16%. Middle 68 is just these two 34s added together. So that would represent 85 to 115. So most people's IQs, almost 2/3 pretty much, 68%, fall between 85 and 115. Okay, and so if I want to do the middle 95%, I think if we go out another section in each direction, we would just have to add that up. So that would be 13 and a half and 13 and a half. That'd be 27 more percent plus the 68 that we already had. That would get us 97. So sorry that, man, my thing is, I need to restart my computer here, but 27 plus 68. So we have 95% that falls between 70 and 130. So we went out one more standard deviation. We got 70 to 130. Okay, so let's do at least one more example like that. And actually, I might make another video. I might restart my computer and then try it again.